Those are online. Are you able to hear, Divya?
Yes, sir.
Okay. You're able to see, right?
Sir, it is just sharing now, sir. Now only, sir.
Are you able to see the PowerPoint?
No, sir.
No?
Now it is okay, sir.
It's visible, no?
Yes, sir.
Okay. Right. So did you all make the notes of that chapter?
Yes, sir.
Yeah. Yeah. Forgot or answer it. Did it? Like I saw it. So today I want to close this chapter. I'm just worried about one thing. I told you that most of the things are deleted, but they're important. Okay. So please pay attention. Don't be under the impression that it's deleted. This will be the last class where I'm going to teach this. I repeat, it will be useful in your calculus. Right? You just tell me the properties. Okay. So till where did we discuss? Which property was the last that we saw? We did some problems also, right? So what were the properties that we saw? I think sine inverse 1 by x is equal to cosecant x that we saw. Cosecant inverse 1 by x is equal to sine x. We saw it something like that, right? We saw the first property. What about the second property? No. So in first property itself, you will have 3. Sine inverse 1 by x is cosecant inverse x. Cosecant inverse 1 by x is secant inverse x, and tan inverse 1 by x will be equal to cot inverse x. That is the first property, right? When you look at the second set of properties, what you have? Sine inverse of minus x is equal to so sine inverse minus x is equal to minus sine inverse x. Similarly, tan inverse of minus x is equal to minus tan inverse x. Similarly, cosecant inverse of minus x is equal to minus cosecant inverse x. Right? Did you note down the values beside them? Yeah, what are the values? So here, where does x lie between? The normal domain. What about tan inverse x? X belongs to? Yes. You can substitute any real number. Cosecant inverse? Modulus of? What is the meaning of this? So this also implies minus infinity to minus 1 union. This also implies, open bracket, no, minus 1 comma 1, because minus 1 and 1 are included, right? All the three mean the same. Am I right? So where do we use this property? Where do we use it? For example, in the previous exercise, sine inverse of minus half was there. What was the procedure I told you? First find for positive value, then add a minus sign, right? Instead of that, what you can do here is you can write it as minus sine inverse of half directly because of this property, right? So answer will be minus 5/6. That's the answer. Am I clear with this? Right. Similarly, tan inverse of minus 1 minus of tan inverse 1. Answer will be, it's simple. Right, this is how we solve. I hope you remember the method which I explained the previous case. Right. Yeah.
Yes, sir.
So what is the next property? Cos inverse of minus x is equal to, similarly, cot inverse of minus x is equal to, similarly, secant inverse of minus x. Everything will be giving you similar result. Pi minus cot inverse x and pi minus secant inverse x. Right. So, for example, you have cos inverse of minus half. How will you write it as? You will write it as pi minus cos inverse of half. So pi minus, what is the value of cos inverse of half? Answer will be, let's see. Right, this is what we did. No, I told you to take the positive value, then do pi minus. Same story. Right. Then. So I hope other problems you can do it. No, cot inverse of minus 1 means. Just cot inverse of minus 1. Cot inverse of minus 1. Pi minus. Answer will be 3 pi by 2. It will belong to the second quadrant. Right. So what is the next property? You will have sin inverse x plus cos inverse x is pi by 2. This is an important one. Sin inverse x plus cos inverse x is pi by 2. Then yes. Then secant inverse x plus pi by 2. Let me take this and I'll show you the proof for it. So if you look at the proof, right? When I take sin inverse x plus cos inverse x, for instance, if I take sin inverse x to be y, then what is x equal to? Sin y. But sin can also be written as cos of pi by 2 minus y. Then pi by 2 minus y is how much? Cos inverse of x. Right. So pi by 2 will be equal to, take the y to the other side, y plus cos inverse x. But what is y? So sin inverse x plus cos inverse x will be equal to pi by 2. Right. I'll tell you where this will be helpful. Differentiability is helpful. See, it's very simple. I'll tell you two places where this is applicable. This is a very, very important property according to me. Okay. One thing is, observe. If at all I have a question like this, sin inverse half plus cos inverse x is equal to pi by 2. Suppose I have something like this. Then they ask you what is the value of x. You need not sit and solve. What will we naturally do? Sin inverse half is, see, for example, instead of half, I have sin inverse of 1 by 3, for instance. You know the value of sin inverse 1 by 3. When it was half, you know it is pi by 6. You will take pi by 6 to the other side and solve. Okay. The logic says sin inverse of something plus cos inverse of the same thing inside should be there, which will lead you to pi by 2. So answer is 1 by 3. That's it. You're able to understand what I'm trying to say. So you directly solve it. This is one way. I'm not sure how many of you have learned this thing. I'll just tell you, you can remember this, why the reason we'll see it in that chapter. If they give you y is equal to sine inverse x, derivative of sine inverse x is given as as of now, remember it like a formula, okay? 1 divided by root of 1 minus x. Okay, if at all, let's say you're following certain steps for this procedure to find out this value. Suppose I ask you what is the value of y is equal to cos inverse x, right? Then what you can actually do here is this cos inverse x, you can actually write it as pi by 2 minus sine inverse x. From this property, you can write it as pi by 2 minus sine inverse x. So when you differentiate on both the sides, dy by dx will be equal to derivative of pi by 2 is 0 minus derivative of sine inverse x, you know already. So this is why when you see derivative of sine inverse x will be positive, cos inverse x will be exactly the negative of it. Similar is the case with tan inverse x and cot inverse x. So this is the reason. I hope you're able to understand, right? So like this, you see this property is very important. It will help you solve the problems faster. Clear with this?
Yes, sir.
Yeah. Any questions? Shall I proceed?
Yes, sir.
What is the next one? So you have tan inverse x plus tan inverse y is given as tan inverse of x plus y by 1 minus xy. Okay. This is also simple. If I take this to be alpha, if I take this to be beta. So what is the question? It is alpha plus beta. So since right hand side is in terms of tan inverse, what you should do is consider tan of alpha plus beta. What is tan alpha? Tan of alpha plus beta? Tan alpha
1 minus.
Very good. So what is the value of tan alpha here? See, alpha is tan inverse x. So tan alpha will be x. Tan inverse y is beta. So tan beta will be
Y.
y, the whole divided by 1 minus x into y. This is tan of alpha plus beta. We don't need tan of alpha plus beta. We need only alpha plus beta. Right? So this is tan of alpha plus beta. So what is the value of alpha plus beta? Simple. No? Similarly, I'll just explain the other part, then you can write it down. If you just change the sign, what will happen? Tan inverse x minus tan inverse y. It will be tan inverse of, sorry, x minus y divided by 1 plus x. Simple, right? Here. So one last property. Shall I proceed? So one last property that you have is something related to 2 tan inverse x. You will have 3 formula, right? 2 tan inverse x, again 2 tan inverse x, and 2 tan inverse x. So this 2 tan inverse x can be written as, so basically what is a 2 tan inverse x is actually tan inverse x plus tan inverse x, right? So what will you get? Okay, we'll go with sine inverse. So sine inverse of 2x divided by 1 plus x square. 2 tan inverse x can also be written as cos inverse of 1 minus x square divided by 1 plus x square. 2 tan inverse x can also be written as tan inverse of, are you able to observe the similarity, some difference between the first and the third? What is it? First one, denominator is plus, here it is minus. Okay. So if you observe, everything comes from the basic definition of sine or sine cos or tan of double the angle. For example, if I have sine 2 theta, what is it? See, 2 sine theta cos theta is something that we know, but it can be written in terms of, how did I get it? So if you observe 2 sine theta, bring this cos to the denominator, it becomes secant. So whenever I have a secant, how will I bring in tan? When I make it secant square. So what I'll do is I'll multiply it with secant theta and I'll divide it with secant theta. So what did I get? 2 into sine theta into secant theta. What is it? Tan theta, because sine theta into secant theta means sine theta by cos theta. So this will become 2 tan theta divided by, this is secant square theta. What is secant square theta? What is the relation? Secant square theta is 1 plus, right? This is how it works. 2 tan theta divided by 1 plus secant square theta. Now if you see, when I have 2 tan inverse x, right? When I have 2 tan inverse x, I will take tan inverse x to be theta. Then what is the value of x? X is tan theta. Am I right? So basically, what is this function? It is 2 times theta. Am I clear till this point? So if you see, all the left hand parts is 2 theta. If you take sine of the 2 theta, right, then what will you get? When you take sine of 2 theta, you can write it as 2 tan theta divided by 1 plus tan square theta. So 2 times, what is the value of tan theta? X, no, divided by 1 plus x square. So 2 theta will be equal to sine inverse of 2x by 1 plus x square. But what is theta? Tan inverse x. Similarly, if I use the logic, what is cos 2 theta in terms of tan? 1 minus tan square theta by, see, using that cos square theta minus sin square theta, you can derive this. Okay, 1 minus tan square theta by 1 plus tan square theta. If you see, in the place of cos 2 theta, theta is what? Tan inverse x, substitute there. Right, take the cos inverse to the other side, you're done, you will get this. Similarly, 2 tan inverse x is what? You can write, what is tan 2 theta? By 1 minus tan square. Again, 2 theta is 2 tan inverse x. Take the tan inverse to the other side, 2x by 1 minus x square. Okay. So, I hope everybody has written it. Right. If not, it is there in those videos. You can always have a look at it. So, where this is applicable is, I'll just give you a hint. If y is equal to tan inverse x, there is something called as dy by dx, which is given as 1 by 1 plus x square. Okay, that is the output. As of now, remember it. Okay. If suppose they give you a question like this, y is equal to cos inverse of 1 minus x square divided by 1 plus x square, differentiate this. They ask you to differentiate this. One way is Start with the derivative of cos inverse and apply chain rule. It will take ages. Okay. Instead, what you can do is use the property. This is nothing but 2 tan inverse x. Sorry. Y is 2 tan inverse x. Then what is the value of dy by dx? 2 into derivative of tan inverse x. That's it. You can solve the problem like this. Clear with this? So like this, the properties will help you in calculus. At that point, you will know the importance of it. So I hope it is clear, right? We'll do, what is the time? 5:20, no? 5:30. Last set of problems from this chapter. Tomorrow we'll start off continuity and differential. Okay. So open your textbooks. How many problems did we complete in the previous class? 2.1 letter, 2.2 we did few problems. No?
Till 17, sir.
Till 17, huh? I think I have a book. 100.
Yes, sir.
Okay, I'm coming. No, page numbers will also change, no? We did 11th, huh? 11, I don't know what, some other problems. Okay. So look at the 12th one. Tan of sine inverse of 3 by 5 plus cot inverse of 3 by 2. Right? This is what we need to solve. We need to find the value of this. If you observe this problem, it's very simple. If I take this triangle, right? If I take this to be theta, sine inverse 3 by 5, if I take it to be theta, then what is sine theta? 3 by 5. Meaning, this side is 3k, this side is 5k, and this will be 4k. Right? Then, what will this value be in terms of tan inverse? See, if sine theta is 3 by 5, what is tan theta from this triangle? 3 by 4, right? Then what is the value of theta? Tan inverse of 3 by 4, substitute it. So tan inverse of 3 by 4 plus. Am I clear with this? You understood how to use a triangle? Anyone having doubt? Okay. So cot inverse 3 by 2, according to the first property, will be tan inverse of 2 by 3. Right? Tan inverse x plus tan inverse y. We just now saw the formula. Tan inverse of x plus y by 1 minus x. So how much are you going to get? So tan inverse of 9 plus 8. 17 by 12 divided by 12 minus 6. 6 by 12. Cancel this and this. So it will be tan inverse of 17 divided by 6. Answer will be 17 by 6. This is the required answer. Am I clear? Clear with this? Shall I proceed? So look at the 13th problem. Cos inverse of cos 7 pi by 6. So cos inverse of cos 7 pi by 6. The options given are 7 pi by 6, 5 pi by 6, pi by 3, or pi by 6. So if you observe, which one is right? So if you write this as 7 pi by 6, right? You are wrong. Why? Because cos inverse of x, right? So what is the principal range of it? 0 to pi, right? But if you look at 7 pi by 6, it is greater than pi. No, numerator is greater than denominator. Then how can you write 7 pi by 6? That's why they gave it as the first option to confuse you. Okay, then what did the answer? So whenever you have these kind of values, whenever it is outside the principal range, you need to do the necessary manipulation. You need to write the numerator in terms of denominator. Don't guess, think. So cos inverse of, see, this is not deleted, by the way. This one you have, this is a part of your syllabus. So listen to this carefully. When the numerator is greater than the denominator, then what you can do is, can I write the 7 as 6 pi plus pi? So cos of 6 pi plus pi, the whole divided by 6. How much is it going to be? It is going to be pi plus pi by 6. Makes sense? Right. Cos of pi plus pi by 6. But what is cos of pi plus theta? Pi plus theta falls in which quadrant? Pi minus is second quadrant. Pi plus is third quadrant. Third quadrant cos is positive or negative? Negative. So what will you get? Cos inverse of minus cos pi by 6. Right. So cos pi by 6, if I treat it as x, cos inverse of negative of x is how much? Pi minus cos inverse of x, which is cos pi by 6. Are you able to understand what I did? The third property. So pi minus, what is cos inverse of cos pi by 6? The answer is yes. So this will be the answer. Clear with this?
Yes, sir.
See, at that time you guessed it or you told it to calculate? You saw in the notes. Okay. I'm asking her. You told the answer as 5 pi by 6, no? 5 by 3, 6. Option D. It's a good problem actually. Shall I proceed?
Yes, sir.
Yeah. You're clear now? Okay. 14th one. Sine pi by 3 minus sine inverse of minus half. Sine pi by 3 minus sine inverse of minus half. Simple. Leave the trigonometric function as it is. Pi by 3 minus. Always solve the angle first, then you can solve the trigonometric function. Sine inverse of minus half. Minus sine inverse of half. Okay. So sine of pi by 3 plus sine inverse half is, so pi by 3 is 30, pi by 3 is 60, pi by 6 is 30. So it will be sine pi by 2. Answer will be 1. So option D. Tan inverse root 3 minus cot inverse of minus root 3. You solve and tell me. What is tan inverse of root 3? Minus. What is cot inverse of minus? Pi minus cot inverse of root 3. Am I right? So pi by 3 minus pi, minus of minus is plus. What is cot inverse of root 3? Pi by, you're correct. Pi by 6. So pi by 3 plus pi by 6 is pi by 2 minus pi. Answer will be negative of pi by 2. Is there an option? Option B is the right. Clear with this? Yeah?
Sir.
Did you all copy? So go to page number 31. So go to page 31. Look at the first problem. In miscellaneous, the first problem is cos inverse of 13 pi by 6. What is the answer?
Sir, in my
So then-
book, it is not there, sir.
Which one is not there?
This sum is not there, sir. In my book, sir.
Page number 31. No? Is it there in others book? Okay, just copy it from the textbook, from the board. No.
Okay, sir.
Okay. Yeah, miscellaneous. So there's miscellaneous problem. Divya, you can make a note from the board.
Okay, sir.
Okay. So cos inverse of cos 13 pi by 6. Answer is definitely not, because it is greater than pi. It is even greater than 2 pi. So what should you do? You will not write it as 6 pi. What is the multiple of 6 which is closer to 13? So you'll write it as 2 pi. So you will write it as cos inverse of cos of 12 pi plus pi the whole divided by 6. See, I'm just initially telling all these steps. Next time onwards, you should write it on your own. 2 pi directly you should write it. So cos inverse of 2 pi plus pi by 6. Right. So cos 2 pi plus pi by 6. Which quadrant is that? Fourth. So first the cos is. So cos inverse of cos pi by 6 is. This is acceptable because it is less than pi. Are you able to understand? See, suppose I want to randomly create a question. Once you complete this, cos inverse of 26 pi by 5. Solve this. Cos inverse of cos of 26 pi by 5. You wrote it as 5 pi plus pi by 5, right? What is cos of 5 pi plus pi by 5? Which quadrant is it? 5 pi plus 4 pi plus is first quadrant, even multiples. Odd multiples of pi plus is third quadrant. Third quadrant la cos will be why 4 pi by 5? You're right, but why 4 pi? Your answer is right, but give me the right logic. Pi minus. Tell them. Okay. 5 by 5 as the answer. No, that's wrong. Because you directly wrote it. I want you to master the concept of quadrants. That is why I gave this number. See, cos inverse of cos of, I hope everybody knows the logic of writing it as 5 pi plus 5 by 5, because you need to look at the closer multiple of denominator. For 26, it is 5. Right. So cos of 5 pi plus 5 by 5 means which quadrant is it? It's very simple. You need not think that much. 2 pi, 4 pi, 5 pi, 5 pi plus third quadrant. You're able to understand. So odd multiples of pi will always fall on the border of second and the third quadrant. Odd multiple minus something second quadrant. Odd multiple of pi plus something is third quadrant. Plus something is there, no? That something should be an acute angle. 5 by 5 is an acute angle. 180 by 5. Okay. So how much is it going to be? Cos inverse of negative of cos. Why did I put this minus sign? Cos of pi plus something is going to give you negative value. So cos inverse of minus x. Pi minus cos inverse of cos pi by 5. So answer will be pi minus pi by 5, 4 pi by 5. Your answer was right. But there is a logic. So it is 4 pi by 5. Is 4 pi by 5 less than pi? Obviously, because the numerator is less than denominator. So these kind of problems we'll be able to handle, no? Shall I proceed?
Yes, sir.
So second one is tan inverse of tan 7 pi by 6. So it's very simple. Tan inverse of tan of 7 pi means you will write it as pi plus pi by 6. So pi plus pi by 6 is tan inverse of tan of pi plus pi by 6 is tan pi by 6, because in third quadrant tan is positive. So tan inverse of tan pi by 6 is going to give me pi by 6. Clear with this? Right. So tan inverse of tan of 23 pi by 6. Solve this. Don't always think in terms of plus. Think in terms of minus also. Answer. Minus 5 by 6. So it's simple. Tan inverse of, correct. You should write it as 4 pi minus 5 by 6. Our mind always thinks in terms of plus, no? But if you see, the nearest value is 24. It is lesser than 24. So 4 pi minus 5 by 6, tan 4 pi minus 5 by 6. Which quadrant does it fall in? Fourth quadrant. Fourth quadrant tan is negative. So tan inverse of minus tan pi by 6. So tan inverse of negative of x is minus tan inverse of tan pi by 6 minus pi by 6. This is the answer. Clear? Okay. So if you see the next set of problems, right, they're asking like this: prove that the third one is 2 times sine inverse of 3 by 5, which is equal to tan inverse of 24 divided by 7. This is what we need to prove. Right. So 2 times sine inverse 3 by 5 is equal to tan inverse of 24 divided by 7. So how do we do this? You already know the formula, right? So we have a formula for this in the first place. That is 2 tan inverse x. That is sine inverse 2x by 1 minus 1 plus x. Here the question itself is 2 sine inverse of 3 by 5. This again simple. Okay. Whenever you get stuck, right angle triangle will save us. So if you start from LHS, okay, LHS you have 2 sine inverse of 3 by 5. You can take the sine inverse of 3 by 5 as theta. If you take it, then sine theta is equal to 3 by 5. So if I take this to be theta, this is 3, this is 5, this is 4, put a k here. Okay. So sine theta is 3 by 5. Then what is tan theta? 3 by 4. So what is theta? Tan inverse of 3 by 4. Meaning, wherever I have sine inverse 3 by 5, I can replace it with tan inverse of 3 by 4. Because they both are connected. Right? So 2 times tan inverse of 3 by 4. Now what you can do is apply the sixth property. What does it say? 2 tan inverse x is equal to, listen, right hand side is in terms of tan. Okay, so directly use this formula. It is tan inverse of 2x by 1 minus x square. So tan inverse of 2 into x is 3 by 4 by 1 minus 9 by 16. Clear? So this will cancel this 2 times. So this will be tan inverse of 3 by 2 divided by 16 minus 9 is 7. 7 divided by 16. This will cancel this 8 times. 8 will go to the numerator. So tan inverse of 3 into 8 is 24 and you're left out with 7 in the denominator. That is what they asked. Clear with that? Did you understand?
Yes, sir.
Yes. Please make a note of it. If any step is not clear, please ask. Hari Raghav, all clear? Ashwin, clear? எழுது இப்போதைக்கு. Shall I proceed now? Yeah. So I'll do one. I'll just give the hints for the other set of problems because everything is similar. From problem 3 to 7, everything is similar. Okay. Shall we do that? Listen. If you look at the fourth one, right, they're saying sine inverse of 8 by 17 plus sine inverse of 3 by 5 is equal to tan inverse of 77 divided by 36. Observe, right hand side is in terms of tan inverse. Here both are in terms of sine inverse. So what is the property we know? Tan inverse x plus tan inverse y. See, actually you can do sine inverse x plus sine inverse y also, but that's not a part of your syllabus. So we'll go only with tan inverse x plus tan inverse y. For that, what did I tell you? Take the right angle triangle. If I take this to be alpha, if this is alpha, then sine alpha is 8 by 17. So 8, 17 means this is 15. 8, 15 and 17 are Pythagorean triplets. Right? So K, K and K. Similarly, if I take this to be beta, then I have another right angle triangle where this is going to be beta, this is going to be 3, 4 and this is going to be 5. So you tell me, if sine inverse 8 by 17 is there, which is alpha, then it will be tan inverse of 8 by 15. I hope you got the logic, right? You need not sit and solve everything. Tan inverse of 8 by 15 plus tan inverse of 3 by 5, no? 3 by 4. You know the formula tan inverse x plus tan inverse y. Apply that, you will get that. Okay. So leave some space for that. You can write down the ideas alone. Right. Similarly, if you look at the 5th, 6th, and 7th also, convert everything to tan inverse. You need to convert whatever question they have given in this kind of sum or difference, convert everything to tan on both the sides. Clear with this?
Yes, sir.
No. So one last problem for the day. Remaining problems you can try it. Okay. So there is a question like this: tan inverse of root x is equal to half of cos inverse of 1 minus x divided by 1 plus x. This is what we need to prove. This is a problem based on prove that. So there are two sets of questions you will get. One is prove that, or they'll say solve for x, which is the next set of problems. If you see from 11th onwards, right, they're asking you to solve the equation. Solve the equation, then you need to find the value of x. Here, you need to prove. So when you need to prove, take either of the sides and then proceed. Whichever is convenient, we can proceed. Okay. So if I take LHS for instance, right? So I have tan inverse of root x. Now logically tell me one thing. I have tan inverse. The question says convert this tan inverse to cos inverse, right? So what I need to do is, and I have a challenge here, which is the square root. So I'll be able to eliminate this tan inverse only if I have a tan here. To get tan there, what should I do? I'll put excess, maybe tan square theta. Right, if at all I do something like this, let's see what is going to happen. So I need it in terms of cos inverse, right? Okay, let's see. So tan inverse of this is going to be tan theta, but this is not going to save us. So it is going to be theta. Okay, let this be 1. Clear till this point? If at all I consider cos 2 theta. Why am I considering cos 2 theta? Is because I took this thing and I equated, see how I thought is, listen, half of cos inverse of 1 minus x divided by 1 plus x is there. No, I considered it to be alpha, for instance. This 2 would have gone to the other side. It would have been 2 alpha. Cos inverse goes to the other side. Cos 2 alpha means I'll be able to get this expression if I do something with respect to cos of 2 times some angle. That is why I considered it. What did I do? Consider cos 2 theta, which is 1 minus tan square theta divided by 1 plus tan square theta. Makes sense? Right? 1 minus, what is the value of tan square theta? X divided by 1 plus x. This is what is cos 2. So what is 2 theta? Cos inverse of 1 minus x by 1 plus x. Theta 2 goes to the other side. Is that not? The question is. So tan inverse of tan theta is theta. So 1 and 2 are same. So LHS is equal to RHS. Got it? Clear with this? Pandalam, you want me to do from RHS to RHS? You should not do that. Because they have clearly mentioned it as half. If you take it to the other side, it clearly gives you the hint 2 tan inverse root x. So then you will apply the formula of cos inverse of 1 minus x by 1 plus. That's not what they're expecting. They want these steps to be true. Okay. Listen. So you might get a doubt, is it always necessary? See, LHS to RHS, this problem looks slightly complicated because LHS is very small, but RHS is. It is always applicable. Trigonometry, you can solve it from both the sides. Okay. If I look at this, since the right hand side is in terms of tan inverse, it is clearly giving me a hint that I need to get cos 2 theta here. So whenever you have this 1 minus x by 1 plus x, now listen to this carefully. Wherever you have 1 minus x by 1 plus x, you can either substitute x is equal to cos 2 theta or x is equal to tan square theta. Why I gave this hint is 10th problem. I saw it just now. Look at the 10th problem. No? What did they give it in the bracket? Substitute. So you're able to understand. Is that problem not having that 1 plus x and 1 minus x? So you will have set of problems where you will have this 1 plus x and 1 minus x. You can either substitute cos 2 theta or tan square theta. That depends on the problem. In this case, I will substitute tan square theta because the left hand side is tan inverse. So if I put x is equal to tan square theta, then what am I going to get? Half into cos inverse of 1 minus tan square theta by 1 plus tan square theta, which is going to give me cos 2 theta. Cos inverse of cos 2 theta is going to be 2 theta. So 2 theta by 2 is going to give me theta. But x is equal tan square theta means what is tan theta? What is theta? So you can solve it from either of the sides. Are you able to understand? Done. So remaining problems you can try. Next class I'll start continuity and differential. First it is 5 pi plus no. Whenever you get a doubt, pi, 2 pi, 3 pi, 4 pi, 5 pi, 5 pi plus something means you are coming here, third quadrant. So third quadrant causes negative. Divya, are you there?
Yes, sir.
Yeah, we can wind up. Huh?
Okay, sir.
You can join the other class.
Okay, sir. Thank you, sir.